All right, class, how's everybody doing today?
Good.
Good. How are you?
Doing pretty good.
Good.
All right, let's go over that last exam. Some people are still mixing problems like this up. About half of y'all can get it no problem. One mistake that some people are doing is they're just taking the X and they're just putting it up there. You can't just move the X where you want to, right? If you have, let's see. We have 1 over X equals 1/2. All right, if that was our equation, you see that X has to be 2, right? So if you just take the X and you just put it up here, well, now X is suddenly 1/2. It's not the same thing. So remember, when the X is on the bottom, you have to flip the fractions, and not just one side, you have to flip them both. So everything that's on the bottom gets moved to the top. Everything that's on the top gets moved to the bottom. And you have to flip the other side as well. 7 becomes 1/7. Okay. Now at this point, because the X is divided by 2, we're going to multiply both sides by 2. And because the X is multiplied by a 5, we're going to divide both sides by 5. So now these 2's cancel, the 5's cancel, and we're left with X is 2 times 1, which is 2, over 7 times 5, which is 35. Okay, and at this point you can check your work. Let's check and make sure that our answer is correct. This, if X equals 2 over 35, it shouldn't hold this equation, meaning we'll plug X 2 over 35, we'll plug that into the X and make sure the left-hand side is equal to the right. So the left-hand side of our equation is 2 over 5x. We replace the X with the one that we got, 2 over 35. We now have, see, 5 times 2, 10 over 35. Now dividing by a fraction is the same as multiplying by its reciprocal. So dividing by 10 over 35 is the same as multiplying by 35 over 10. So we have 70 over 10, which is 7. And that is the right-hand side. So it checks out. All right, any questions about that? All right, let's see. For number 2, I'm happy y'all got this one right too. A lot of y'all made the mistake of getting 17% of 80. We're not asking for 17% of 80. We're asking what percent of 80 is 17. Meaning if you take 80 and multiply it by some percentage, you get 17. Right? 17 is what percent of 80? So that's your setup. And now to solve it, we're simply going to divide both sides by 80. So X is 17 over 80. And if I can find my phone. There it is. Seventeen over 80. 17 divided by 80. Make some more room here. Is 0.2125. And as a percentage, that would be 21.25%. Okay. So some of y'all did this. You said, okay, I got 80, take 17% of it. That's not what we're asking for. Okay. So there's three different kinds of percentage problems. You have basically a number times a percentage equals a number. Let me use different letters here. A number times a percentage equals another number. There's always three variables. The problems, they always give you two numbers and you're finding the third. So you just have to set it up properly. All right, so keep practicing on your percentages. Any questions about that? Okay. So here's your quiz number 4. I'm getting these from here on out, the quiz and exam problems, I'm going to get them from the textbook. If you notice on page 19, there's homework section. I'm going to be pulling all the exam and quiz problems from the homework section. So I recommend that you work these homework problems ahead of time. Okay. This is where we left off. So let's see, it's what, 10 past 3. So we'll take 15 minutes for the quiz. So it'll be 3:25. We'll get back to this, okay? And then we'll review it 3:25. Recording. Okay, let's check out number 1 here. We have 36% of what number is 33.12. So we're looking for a number and we're taking 36% of it. So we got a number, we're taking 36% of it, and that's giving us 33.12. So to solve for our x, divide both sides by 0.36. Actually, let me do this step by step. Have the setup here by itself. So there's our setup. And let's see, 33.12 divided by 0.36 is 92. All right, everybody pull that one off, okay?
Yes, sir.
Yes.
All right. See, there's 3 numbers. They give you 2 of them. You find the third. All right, number 2, this one's pretty easy. Yvette knows the names of 8% of the students at Northwest Vista. If there are 15,435 students, how many students does she know by name? Well, she knows 8%. So we take 8% of 15,435. I get 1,234.8. All right, any
It's like the 0.8. She kind of knows, but she's not 100%.
yeah, she can remember that student's name 80% of the time, right? All right. We are in the textbook here on page 18, I believe. And we're on number 28. All right, if the Spurs finish the season with a record of 55 wins and 27 losses, what percentage of their games will they have won? Round to the nearest 0.1%. All right, well, first off, we need to know how many games they've played. Find the percent that they won. So the total is
82.
wins plus the losses, right? So 55 plus 27,
82.
what, 82?
Mhm.
So 82 total games, and they've won. The wins compared to the total is going to give us our percent. We have 55 out of 82, which is 5,
0.67073,171.
67073,171, right? Which is, let's see, 67.073%, or rounded to the nearest 0.1. This 7 turns that 0 into a 1, so we have 67.1%. All right, not too bad. Oops, missed it. Try this one. $29. All right, if the Spurs begin the season with a record of 7 wins and 4 losses, predict how many games they will win throughout the 82 games of the season. All right, so set up as a percent and solve. Well, let's see. 4 makes 11, right? So
Yeah.
we're 11 games into the season. So part A, the percent won so far is 7 out of 11, right? Which we can convert that into a percent, right? Let's see. 7 divided by 11. So 0.6363, or 63.63%. So if that's their percentage that they win, if they keep with the same percentage, we just need to find 63.63% of 82. Now, instead of putting 0.6363 here, instead of doing that, I'm going to put 7 over 11, because this is an exact number. This was just an approximation, right?
Mhm.
It's the same value. So I'm going to use the 7 over 11. So I get an exact number. I don't want to lose information if I don't have to. Oops, 82 times 7 divided by 11 is 52.182. I'll round it to there. So approximately 52 wins. Now we're going to set this up as a proportion. Well, we compare wins to the total, wins to the total for the whole season, right? So this is what we have so far in the season. Won 7 out of 11. So how many out of the whole season? So to get X by itself, multiply both sides by 82. Notice we have X equals 82 times 7 over 11, the exact same thing we had up here, right? So 2 different approaches as far as conceptually, but same answer. Page 19, this is a homework section. Again, I'm going to be getting all the quiz and exam problems from these homework problems that are in the textbook. These are separate from the homework problems that are in the separate homework packet, okay? I'll be pulling the exam and quiz problems from these homework problems out of the textbook itself. think we just worked number 2 here in the quiz. By the end of the semester, we should have worked them all in quizzes and exams. And that's where the final will be coming from. So you can see there's lots of about 3 pages, 4 pages of problems.
Wow.
So there's where you can get some practice in is working these. Okay. All right, page 25. Moving on to exponents. Multiplication is a notation that's for repetitive addition. So like 2 times 3, that's just 2 plus 2 plus 2, right? So we don't actually need multiplication. We could just do everything with addition. Now, all we really need is the number 1, because you know the number 3 is just 1 plus 1 plus 1. But if we only use the number 1 and addition, math would be really, really hard, even for simple problems. So we invented other numbers to make multiple ones easier to deal with. Then we invented multiplication to deal with repetitive addition. And now we're dealing with, we created exponents to deal with multiple multiplications. So like 2 cubed is 2 times 2 times 2, right? So a to the n would be a times a times a n times.
They call these powers, right?
Yeah.
Okay.
Exponent or the power to the power of. So 10 to the 3rd power, or 10 cubed, would be 10 times 10 times 10, or 1,000. Notice when you multiply by 10, you're adding a 0, right? 10 cubed, that's really 1 times 10 cubed, right? Or 1.0. Sometimes we use the cross to represent multiplication. So this would be, we just move the decimal 1, 2, 3 times. That's 1,000. All right, so 10 to the 1st power. Anything to the 1st power is just that number. This is just 10. Okay. 10 squared is 10 times 10, or 100. There's a reason why they call it squared and cubed, because squared represents an area, cubed represents a volume. After that, it's just to the 4th power, 5th power, and so on. 10 to the 4th, 10 times 10 times 10 times 10. So that's a 1 followed by how many zeros?
4.
Yeah, 1, 2, 3, 4. 10,000. 10 to the 7th. 10 times 10 times 10 times 10 times 10 times 10. 2, 3, 4 times 10, which is a 1 followed by how many zeros?
7.
1, 2, 3, 4, 5, 6, 7.
So you always add the first number, right?
Come again? The 1?
Yeah, so it's like 10 to the 7. So the 10 counts as one of the numbers. It's not like 10 to the 6.
Right, there's 7 10s here multiplied together. So whatever
Okay.
number is up there, that's how many times you're multiplying it together.
It's just whatever number 7 times or 2 times or 4
If you look at
times.
20 cubed, that's 20 times 20 times 20. Right? So specifically,
So instead of doing 3 zeros like you're doing in 10, you would do 6 zeros?
come again? What's
If you're doing, like, if you're going by that same, the 10 to the 4th power is 10,000. So you just add those 4 zeros.
that only works with 10s.
Okay.
Yeah, it only works with 10s. So See, like 20 cubed is 20 times 20 times 20. So that would be 20 times 20.
400 times 20.
That'd be 8,000. Okay. So, but 10 is nice because you just add a zero. That's why the metric system uses everything in base powers of 10. You know, 10 centimeters, 10 millimeters, and so on. So, if I'm going the other way here. What would this be as a power of 10? 10,000.
10 to the fourth power.
That's right. What about this one over here?
10 to the 8th.
6, yeah, 10 to the 8th.
And you could find these answers by just dividing it by 10, right? Or no, probably not.
Dividing by 10, yeah. Yeah, exactly. How many times you have to divide by 10? So divide both sides by 10 to the 4th. All right, and you'd get down to 1. All right, now for negative exponents. Squished it. So if a positive exponent tells you to multiply that number over and over again, a negative exponent tells you to divide over and over again. So 10 to the negative third, which is the same as 1 times 10 to the negative third. Okay, we're taking that 1 and we're dividing it by 10 3 times. So it's 1 over 10 times 10 times 10, which is 1 over 1,000 or 1 over 0.001. So be careful here. Yeah, it's 10 to the negative 3, but notice there's only 2 zeros. All right, that's because we started off with a 1 and we moved the decimal to the left 3 times. That's what that, when you do a 10 to the negative 3, it's moving the decimal to the left. Before, you were moving the decimal to the right. So like 10 to the 4th, right? That's 1 times 10 to the 4th. It's really 1.0 times 10 to the 4th. That's all just 10 to the 4th, right? But if you take that 1.0 and you move it, the decimal 4 times, 1, 2, 3, 4. That's why you get those 4 zeros. So be careful on your negative exponents. You can't just say, oh, there's a 3, so I got 3 zeros. It's 1 left, 1 less. It's only 2 zeros because of where the decimal started out. It started out on the right side of the 1. So what if you had 1 over 10 to the negative 3? Well, 10 to the negative 3 is 1 over 10 cubed, right? That's what this guy is here, 1 over 10 cubed. And dividing by a fraction is the same as multiplying by its reciprocal. All right. So negative exponents mean divide. All right. So if you have a negative on the bottom, that's like having a positive on the top. Does that make sense? So 10 to the negative 3 is 1 over 10 cubed, or 1 over 0.001. 10 cubed is 10 times 10 times 10, or 1,000. All right, you'll get to practice with this plenty. So the key here is when you have the negative exponent, you're dividing a lot. That means it's going to make your number smaller. Sorry, I did this wrong here. Did that wrong too. All right, sorry about that. When you're dividing by 10 over and over again, the number gets smaller and smaller and smaller. 1 over 1,000 is the same as moving the decimal to the left 3 times. So it started here and we went 1, 2, 3. So 10 to the negative 3 is a really small number, 0.001. 0.001. 10 to the positive 3 is a really big number. Okay. Sorry about that. I screwed that one up pretty good. Let's do some practice here. So 10 to the negative 1 is 1 over 10, or 0.1. 10 to the negative 2 is 1 over 10 times 10, or 1 over 100, which is 0.01. So notice we started with the 1 and we moved the decimal to the left 2 times. So 10 to the negative 4, all right, we're taking 1 here because this is really 1 times 10 to the negative 4. So we start off with the 1. We're moving the decimal to the left 4 times. 1, 2, 3, 4. So notice there's 3 zeros there. So 10 to the negative 7th, start off with 1. We go 1, 2, 3, 4, 5, 6, 7. 7 decimal places. So notice there's 6 zeros there. So when you raise 10 to a negative power integer, integer power, you're moving the decimal to the left 1 unit.
Quick question.
Yes.
Can you hear me?
Yes, I can.
Oh, sorry. I don't know if you heard me. So I understand how to do it and why, but my question is the 1. Is it because you have to divide that it has to be a fraction where the 1 is coming from?
It doesn't have to be a 1. Anytime you have just a number, it's the same thing as 1 times that. We're going to start looking at examples of like 3.4 times 10 to the negative 4.
Mhm.
Okay, so what that would be is you're taking this decimal, we move it to the left 4 times. 1, 2, 3, 4. Okay, so we're aiming to get to a scientific notation. We don't like to work with numbers like this. We prefer to write them like that.
Yeah.
Okay, does that make sense?
Yeah. Thank you.
Okay. Well, for the meantime, we're just dealing with 1s here. So this guy here would be 10 to the negative what? Let's see. We'd start off with 1, but we'd move the decimal to the left 1, 2, 3, 4, 5 times. So this is 10 to the negative 5. This one we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 10 to the negative 9. So mathematical order of operations, all right? You have to do the exponent before you multiply, okay? So this is 5 times 10 to the cube means 10 times 10 times 10, all right? So this would be 5,000. This is not equal to is 50 cubed. You don't multiply the 5 times the 10 first. The exponent has to be done first. Okay. And remember, there's lots of different symbols for multiplication. Sometimes you just write the numbers next to one another. Sometimes they put the cross, and sometimes they put a dot. It all means the same thing. For scientific notation, they typically use the cross though. Okay. So if they write this, all right, this is 5 times 10 cubed, or 5 times 1,000, or 5,000. Check some of these out. Follow correct order of operations and evaluate the following. All right, 7 times 2 to the second power. That's 7 times 100, or 700. 3 times 10 to the -4. All right, we have a 3. This is really like a 3.0, right? What we're doing is we're moving the decimal to the left 4 times. 1, 2, 3, 4. Okay. All right, scientific notation. They always like to make this number here at the front. It's a number between 1 and 10. Right? We wouldn't have like a 17.45. We'd move the decimal over till where that number is always between 1 and 10. Okay, so this guy here, we're gonna have to move the decimal to the right 6 times. So 1, 2, 3, 4, 5, 6. So 745,000. This guy, we need to move the decimal, oops, to the left 6 times. So it starts here. We go 1, 2, 3, 4, 5, 6. All right. The 10 to the -6 makes this a really small number because you're dividing by 10 over and over again. All right. 10 times 3 squared. 3 squared is 3 times 3, which is 9. So we get 90.
So 10 times 9 is 90.
Yeah. All right, number 20 here. This is 3 times.
Real quick on the last one, you do parentheses first, right?
Yeah. It's the exponent. You got to do the exponent first.
Okay, that's what I thought.
So that
Is it like that PEMDAS? Please excuse my dear Aunt Sally.
I'm not sure. I don't remember that.
Parentheses, exponents, multiplication, division, addition, subtraction. Like it goes in that order.
Yeah, kinda, but it's you can put parentheses anywhere. Like this thing right here is the exact same thing as this. It's the same thing as this, right? So they didn't actually have to use the parentheses here. They're using the parentheses to show multiplication. The key is you do the exponents before you do the multiplication.
So you're just working with E and M.
Yeah. So that, I mean, yeah, I'd have to think about it to make sure that that's always the case. But yeah, typically, if it's in parentheses, you have to do what's in the parentheses first. Yeah. So like this over here, I used parentheses, right? But all I was doing was using the parentheses for multiplication. The 2.54 squared is 2.54 times 2.54. And this, you can multiply these in any order now. You know, you can multiply these two and then times that, or you can multiply these two and then times that, right? Because 2 times 3 is the same thing as 3 times 2. So if we do this, let's see, 2.54 times a 2.54 times a 3 is 19.3548.
Wouldn't 17 be 7 million?
This one?
Not, no, yeah, not 745, because if you went over 6 times, there would be another 0, right?
maybe 1, 2, 3, 4, 5. Yeah, I'm missing another 0. Thank you.
No problem.
Right. This one would be 7 times 12 times 12 times 12, which is 7 times 12 times 12 times 12, 12,096. I think there's a power button on your calculator for doing the exponents. Right? On an iPhone, you have to turn your phone sideways to get power button. Power button looks like it says X to the Y. That's the button you use to do exponents. So this guy over here, we have 1/4 cubed. So we're multiplying this by 1/4 over and over again, which can also be written like this, which can also be written like that, the negative exponent. But however you want to write it, we have a 40, and then we're dividing by 4 3 times. 40 divided by 4 divided by 4 divided by 4. 40 divided by 4 divided by 4 divided by 4 is 0.625.
For 22, why is it a negative exponent?
Because we're dividing by 4 3 times.
Okay.
Remember the
Oh,
negative
duh.
means divide. Yeah.
Okay.
All right, so let's spot the error between here and here. What did they do wrong?
They divided 3 times 4
Well, they multiplied,
or multiply. Sorry, yeah, I'm assuming.
multiplied 3 times 4 before doing the exponent. So these are not equal. This is 3 times 4 times 4. So 3 times 16. Right, which is not equal to 144. And then they throw in some simple fractions for some reason here. Sometimes I wonder about the order as people do things in. So for 24, the 8's cancel and we're left with 5, right? 25, the 4.5's cancel and we're left with 7. So to simplify these, we can rewrite 10 here as 2 times 5. We have a 5 on the bottom, so the 5's cancel. We're left with 6. For 27, we can rewrite the 12 here. What, a 3 times 4? 5 times 7. And on the bottom, we can rewrite the 6. See, as a 2 times 3. Actually, this 12 up here, we do not want to just do 3 times 4. Let's do 3 times 2 times 2. Right? 3 times 2 is 6 times 2 is 12. So that way, we can cancel these 2's, cancel those 3's, cancel those 5's, and we're left with 14.
Oh.
right, for 28 over here, let's see. Let's break it down as far as we can. 15 is 3 times 5. Well, we can cancel the 8s and the 7s already, right? So we don't even need to do that. Just cancel the 8s and the 7s when we have 15 over 4. And we can't reduce that because 15 is 3 times 5 and 4 is 2 times 2. So there are no like terms, so we stick with that. This one is kind of odd. There's nothing to cancel. There's nothing but ones on the bottom. So 9 times 11 is 99, times 2 would be 198. All right, for 30 here, 9 is 3 times 3. And then we have a 3 times 3 on the bottom. So the 3's go away. 10 times 5 is 50. 25 is 5 times 5. 4 is 2 times 2. So the 2's go away, the 5's go away. So all we're left with is 1. The bottom is the same as the top. All right, before we move on to this, it's 4 o'clock. Let's go ahead and take a 15-minute break, if y'all are cool with that. And we'll come back and knock out these perimeters. So yeah, 4:15, we'll get back on it. All right, class, we're back. Let's see here. So they want us to find the perimeter of the equilateral triangle. The perimeter just means the distance around it, right? Like the fence, if you will. Equilateral triangle, just means all 3 sides are the same. So the perimeter here would be 24 yards plus 24 yards plus 24 yards. You always want to write your units. Because if you leave those off, then you don't know what units you end up with. So if we add those together, we get 72 yards. Number 33, we need to find the fencing to enclose the rectangle. So we got 24 feet plus 13 feet plus 24 feet plus 13 feet. So that's 24, 13, and 13, 74 feet. All right, always write your units. All right, so now we're looking for an area. Remember, area is length times width, right?
First one is 64.
That's right, 8 meters times 8 meters, 64 meters squared. Notice we have meters times meters. So our units are squared now, 64 meters squared.
And that one's 312 feet.
312 feet squared, right? That's what they're trying to emphasize here. So we got 24 feet times 13 feet, which is, what was it, 324?
Hold on. Yeah, no, 312.
300, if I can just write.
Let me double check. Hold on. Now you're making me question myself. Yeah, it's 312.
312 feet squared. You got to put the feet squared in there, otherwise it's wrong. Because 312 feet is a length, right? 312 feet squared is an area. So let's look at volumes. So the volume of this cube, all right, volume, length times width times height, 5 inches times 5 inches times 5 inches. 5 times 5 is 25, times 5 is 125 inches cubed. Inches cubed is a square, a cubical inch, right? It's an inch by inch by inch. We got 125 of them. So the amount of sand needed to fill a box measuring, let's see, we'll draw our box here. We got 24 feet. All right. By 13 feet by 3 feet. So our volume here is 24 feet times 13 feet times 3 feet, which is 24 times 13 times 3, 936 feet cubed, cubic feet. Page 29. What exponent indicates length, area, and volume? The length, the exponent is a 1. We don't write that though. If you have meters to the first power, that's just meters, right? Area, squared, volume, 3, right? That's why it's called squared, because a square has area. And this is called cubed because cubes have volume. And then after that, you have to the 4th power, 5th power, and so on. All right, some of these we're gonna have to look up. I don't remember a lot of them. Let's see here. I could put this up here. All right, cm is what, a centimeter, right?
Right.
All right, and a centimeter is a length. And as far as imperial or metric, that is metric because it's a centimeter, and the meter is the basis of length in the metric system. All right, the US is the only country that doesn't use the metric system. We use the units that were based on the length of the king's foot and the king's thumb, even though we don't believe in kings, which is interesting. So a centimeter cube, that's a length times a length times a length, which gives us a volume, since it's based in meters, metric. Inches is the length of the thumb, and so inches squared is an area, and that would be imperial, British. All right, it's not based in metric. Grams is part of the metric system. The metric is based on meters, grams, and
Math, right?
I forgot the other one. I'll have to look it up. Meters for length, grams for weight. For volume. I don't know. We'll figure it out when I look it up. The grams here is a mass, and it is metric. HM is a hectometer. So it's, I forget how many that is. It's like, it's 10 like to the 6th meters, something like that. So it's a length. And that meter there says that it's metric.
I thought you were trying to trick us. I thought it was H&M like the clothing store. I'm like, what is that?
I'm gonna try to trick you. Let's see, a dag. I forget what a dag is. A lock of wool matted with dung hanging from the hindquarters of a sheep.
Perfect.
That's what it is in Australia. Hold on, dag unit. So it's an Australian dingleberry, but it's also a decagram. That's it. Decagram.
So should I write dingleberry down as a unit of measurement?
Yeah. It is a unit of mass in the international system of units, all right, which is the metric system. So it's a mass right here, and it's metric because it's based in grams, which are the metric system. Years would be time. That's both imperial and metric. However, a light year would be a length. It's the distance that light travels in 1 year. DL, let's see. Make sure I get it right. DL is a deciliter, I think. Down, I
Deciliter?
think so.
I said deciliter.
I think that's what it is.
Let's see how far I get.
Deciliter, yeah.
Wow.
Oops. Yeah, that's right. Liter. Deciliter.
Nah.
You got centiliters and so on. So yeah, it's the liter is in the metric system. I wanted to make sure if I wrote that down. So metric is meters, grams, and liters. Okay, so a deciliter is it's a volume. Just like you'd have a volume of a liquid in a water bottle. Okay, and it is metric. All right, a dam squared. Let's see, dam unit. It's a decameter squared. Meter squared. So it is how many? We'll get to these prefixes: hecto, deca, centi, and so on. We'll have a chart of those later, and it just tells you how many times you're multiplying by 10 or how many times you're dividing by 10. But since it's a meter squared, that gives you an area. And since it has meter in it, it is metric. This is a millimeter cubed. All right. So that would be a volume in the metric system. M is just your meter, your basic unit of length metric system. MI is your mile. That is Imperial British. So we're going to get to play with all these units here pretty soon. Now, they're asking us for a unit ratio. All that is the number 1 and writing it in a smart way. All right, so the number 1, using this relationship, since 1 inch is the same as 2.54 centimeters, this is a unit ratio. The top is equal to the bottom. We could also write it like this: 2.54 centimeters over 1 inch. Now, why do we want to do that? We use these smart ones in order to convert units. What if we had 17 centimeters and I want to convert that to inches? Well, if you multiply by 1, it doesn't change anything, right? So what we'll do is use a smart 1. We'll rewrite that 1 as a ratio. Now we have centimeters. We want to get rid of the centimeters, so centimeters go on the bottom. Okay, and I forgot to write. There we go. We want to get rid of centimeters. We want to end up with inches. All right, we know that 1 inch is 2.54 centimeters. So this is the number 1. And we're just using it to convert. The centimeters go away and we're left with inches. So 17 divided by 2.54, 6.69 inches. So we start off with centimeters, now we have inches. So we use these relationships to make unit ratios in order to do unit conversion. So over here, 12 inches is the same as a foot, or 1 foot is the same as 12 inches. And you'd use one or the other depending if you're converting from inches to feet or from feet to inches. All right, 1 foot is 0.3048 meters. So about 1/3 of a meter. Or you can write it the other way. It's the same as a foot. Miles squared, an acre is an area, so you have to have miles squared. So number 1 is the same as the ratio of 1 mile squared to 640 acres. Or 640 acres compared to 1 square mile. So a liter, remember a liter is a volume, like a volume of liquid. 1 liter is, what is this? Not a tenth, not 100, 1,000th of a meter cubed. Okay. So I think that's a cubic millimeter. Not cubic. The other way around. Liter is 1,000 millimeters cubed. That's where we're going. So 1 liter is 0.001 meters cubed. Or the other way around. 1 yard is 3 feet. So comparing 3 feet to 1 yard, or compare 1 yard to 3 feet. So we get some more here. All right, 9 feet squared is 1 yard squared. That should make sense. If 3 feet is 1 yard, right? If you square both sides of this equation, when you do that, you have to square the whole thing, right? So we square the 3 to get 9, and we square the feet squared. So 1 squared is 1, yard squared is yard squared. So 9 feet squared is the same as 1 yard squared, or 1 yard squared is 9 feet squared. Over here we have ounces. I have ounces as a volume, right? You could think of, they have different kinds of ounces. Sometimes they use it as a weight. All right. Sometimes they use it as a volume. Usually they'll say fluid ounces when they're referring to a volume. So I think the way it works is if it's water, 1 ounce weighs the same as hell, I don't remember. I'll have to look it up. When you come to like these units, sometimes it's ambiguous. You don't know which one they mean, you know, because like there's in the tons, there's the imperial ton, the metric ton, and different kinds of tons depending on the material that you're talking about, a ton can be a different number. We have 1 ounce, the same as 29.5735 centimeters cubed. So here our ounce is a volume, centimeters cubed makes an ounce. Now this is finally leading into scientific notation. All right, so we've already covered this. 10 times 10 is 10 squared. 2,000 would be 2 times 10 cubed. All right, so 2 million would be 2 times 10 to the 1, 2, 3, 4, 5, 6, 6th power. And here's our scientific notation. So scientific notation looks like this. A number between 1 and 10 times 10 to an exponent. All right, so that's a number in scientific notation. This would be 1, 2, 3, 4, 73,000. Okay, so working with really big or really small numbers, we usually use scientific notation. We already saw, okay, write 1 divided by 10 over and over again using the pattern above. This would be 10 to the negative 1, 2, 3, 4, 5 times, right? So we're dividing by 10 5 times. Here's some examples. So the following numbers are written using powers of 10. 0.5, that's 5 times 10 to the negative 1. So notice this 10 to the negative 1, you're dividing by 10. That's saying take the decimal and move it to the left 1. You get 0.05. This one says move it to the left 2. Boom, boom. And the next one says move it 3 times. So it starts here 1, 2, 3. So notice these are small numbers. 10 to the negative dividing by 10 gives you small numbers. So this guy says move the decimal to the left 5 times. 1, 2, 3, 4, 5. Okay. So when you have a number like this, you want to shift the decimal until you have a number that's between 1 and 10, and then write the correct exponent. Okay, these, we're all gonna have to start searching the web for these because these are hard. So they give us some examples. 1 meter, an example of a meter is the length of a guitar. So like 1 centimeter, that would be like the width of a thumbnail. What about 1 millimeter? Can anybody think of an example of something that's a millimeter? Somebody said in the last class, thickness of a credit card. All right. A hectometer is 100 meters, right? The length of a football field. All right. Football fields are 100 yards though, right? Meters are close to yards. All right, something that's a length of a kilometer. Since we do everything in miles here, it's hard to think of what a kilometer is, right? It's close to a half a mile. I think it's a little more than a half a mile. So something that's a half a mile long.
The houses in my neighborhood.
The houses are half a mile long.
No, like to get to somebody else's house. I don't have anything half a mile away from me.
Okay,
I thought you were saying the house. I was like, man, I want to live in that house.
yeah.
Yeah, it's half a mile long and about a foot deep.
So length of a big ass house. Right.
Where I'm from a small country town in Wisconsin, and the houses are like, I don't know, 2-3 miles apart. So you have a bunch of acreage. So if you need like sugar from your next door neighbor, you just hop on your snowmobile or your four-wheeler and head down.
Not a snowmobile. My gosh.
See, that's what I was trying to get at, like to the next house, but. that doesn't
Always
work.
bring a case of beer. It's rude if you don't bring beer.
Yeah. 6-pack of beer for a cup of sugar.
Yeah.
It's a fair trade. We really use that. Like down here, it's like, here, I'll pay you $40 for your service. Up there, it's like, here's a 6-pack and like some cheese curds.
Sounds about right. Go to the store once a month. All right, 1 inch. That was originally based on the length from what, the knuckle to end of thumb. All right, so that's why we had to come up with the metric system, was because you use units in commerce. So back then is like they were using their feet and, you know, their forearm or the length of, you know, ear or whatever, and different people are different sizes. So in order to have commerce more precise, and when you're doing international commerce back then, you know, some people were using thumbs and other people were using, you know, pinkies. So it became difficult to do the conversions for them to do marketing and stuff.
My grandfather was a carpenter and he always used this as his measurement of an inch. So
Okay.
he would line it up like right there.
I did the same thing.
Did you? Yeah.
Yeah.
That's cool. My brother used to make fun of me because of how I'd measure stuff when I first started doing carpentry. He's like, yeah, it's about 3 apples tall, you know, like a Smurf.
But not every apple's the same size. So how would you?
Well, not every Smurf is the same height either.
That's true.
All right, 1 yard. Let's see, what is a yard? That's what we use, right? Yards.
Yeah, it's like 3 feet.
It's close.
It was rough, but yeah.
Yard. It's 0.91 meters. Yeah, it is 3 feet, isn't it? Yeah, 1 yard is 3 feet.
You're welcome.
So it's about 3 human feet. All right, now we got a mile. That's how far they make you walk in elementary school. What do they call it? They call it the rec walk when I was a kid. We all had to go walk a mile, I think once a week or something.
Well, does that sound like you got to go out to the yard in prison or something? Like,
Wait, how did you guys only get to walk a mile? We always were told to do timed miles and they were like 1.5 miles.
Oh no. That's terrible.
Same here. There was kids puking.
Yeah.
Yeah, that'll happen. You gotta take it easy. All right, a gram is about the mass of a paper clip. So a kilogram, let's see, it'll be a kilo. I don't know, 1,000 paper clips.
we'll go with that.
Yeah. All right, this would be a microgram, 1,000th of a gram, is less than a grain of salt. 1 liter or bottle of water something like a liter.
Like one of those big ass bottles of water, like those clear American sparkling water things you buy at Walmart.
Big,
I think those are liters.
big ass bottle of water. Yeah. I
Yeah,
remember the
emphasize the
3 liter
ass part.
jugs, you know, with the Coca-Cola or whatever. It's the big one. The big one.
Those are the
I
things
don't know if
that
they sell those anymore. I think they only
Super
make
Troopers, dude. He's like, I need a liter of cola.
diabetes in a bottle. All right, this one here is a milliliter. 20 drops of water. All right. A quart, I think this is a quarter gallon. Okay. 1 fluid ounce. They got to say fluid ounce to separate it from the other kind of ounce, because a fluid ounce is a volume. And there's another ounce that's a
Shot glass.
huh?
Isn't 1 fluid ounce like a shot glass?
It's 1/16 of a fluid pint and 1/128th of a gallon.
Somebody's an alcoholic in this group.
No, I'm from Wisconsin. It's a measurement thing.
Yeah, we use fluid ounces here. Well, let's see. It's the U.S. Fluid ounce is about 4% larger than the imperial fluid ounce. So just between here and Great Britain, we're using slightly different fluid ounces. The difference between a fluid ounce and an ounce is that a fluid ounce is used for measurement of fluids and their volumetric properties, whereas an ounce is used for the measurement of mass and weight of the solid materials. So a fluid ounce is a standard unit for measuring the capacity of a liquid. These last ones here. All right, a square centimeter. It's about that big. All right. I don't know how big your screens are, but that's about a square centimeter on my screen. 1 meter squared. It's a square meter. The area covered by a large opened umbrella. All right. 1 acre. Let's see.
That's 2 house plots. Or 4 house plots. Sorry, 4.
2 or 4 house plots.
Yeah.
I think where the acre came from originally was like the farmland that one farmer with 1 ox could plow in a day, something like that.
That wouldn't surprise me.
Land area, 1 farmer with 1 ox
I'm gonna have to rent an ox and test this theory.
plow in a day. I looked it up and they said something about chains and furlongs and some other stuff. Those were all different ancient units. I don't know. But I heard this on Stuff You Should Know podcast.
Chains are usually from survey, so that's what I used to do.
Oh yeah, that was my first job. I carried that pole that had the little bubble in it. You walk around on the properties and
Hell
find
yeah.
the nail and hold the pole.
Is there anything you didn't do?
There's plenty of stuff I haven't.
Yeah.
But I did that one when I was 13. I carried the water and that metal pole. And we did like a 60,000 acre ranch in the hottest summer that we'd ever had.
Dude, we used to have to work downtown and like plumb it up. If you know what I'm talking about, plumbing it up with the bubble.
Yeah,
Like-
exactly.
Yeah, and then you have to do like, I don't know, 10,000 points in a day or some ridiculous stuff.
We only had a handful because we'd have to walk for hours to get from like one nail to the other nail because it was a giant ranch. So we are just hacking through cedar the whole time. And by the end of the day, I'd be covered from head to toe with seed ticks. There's billions of tiny little ticks.
I feel your struggle, dude. I feel your struggle.
Wash them off. And
I did a survey in College Station and we were covered in poison ivy like the whole week after that.
No, it's terrible. Terrible.
It wasn't poison oak.
Right? It's probably a mixture of both. All right, let's see. So let's end it there and let's see if I can. What was the exam? Give me a second here. Now open sesame. So here's your exam number 4. All right, and I pulled these problems from the homework section that starts on page 19. All right, so we do not have class Monday because it's a holiday. So I guess I'll see y'all a week from now on Wednesday. Yeah, try to get your answers uploaded by midnight, and I will see y'all later.
Bye.
Okay, thank you.
Be safe.
Goodbye.
Bye, everybody.
Have a good one.
Have a
Yes, have a good
question.
week. Bye, everyone.